A confirmation about the audio, please, guys. Is the audio clear and available? Thank you. Okay, till now, the portions that we have covered, is that digestible or is it something which is too much? The portions of geomorphology that we have covered. Okay, digestible. Midway. Midway also works. Are you able to wrap your head around the imagination that is required, that how is it that the plates could move, how is it or what is it that Wagner actually proposed, why it was incorrect, what is the internal structure of planet Earth? Are you able to wrap your head around it? Abyssal plains, Anjan, are the deep sea plains. At the bottom of the ocean, you have flattish plains. We'll study in oceanography as well. Yes, over imagination is required, Weber. Twisha, daylight saving time is, for example, the time zone in India, the standard time is followed with the meridian which passes through the region of Allahabad. Now, in the region of, for example, I'm just giving you an instance. For example, in the region of Arunachal Pradesh, sun will rise much earlier, right? And basically, let's suppose if your working hours are 9 to 6, yeah, and basically you would want to utilize sunlight as much. But what if the sunrise happens at 4 a.m. and sunset there happens at around 4:30 p.m. itself? So that is why you basically wind back the clocks during the summer and move it forward again during the winter in order to adjust for that daylight. That is what is the daylight saving time, the concept of it. Ankush, seafloor spreading is not completely acceptable, but it significantly helped us understand the circulation of the oceanic crust and the oceanic seafloor. Devyani, we had discussed about the format of answer writing with one of the questions about continental drift. Tomorrow, if possible, or when we get to the end of geomorphology, when we shall be discussing all the PYQ. So here, the pattern that we shall be following, guys, is after each of these major units, geomorphology, climatology, oceanography, that is when we'll pick up the bulk questions. Okay, so both prelims and the mains PYQs. So there again, we will talk about it. Yes, Weber, they are the same. Okay. So today, we initiate the discussion from the divergent plate boundaries. And as we initiate the discussion about the divergent plate boundaries, it is a kind of a great coincidence that the region of Iceland, rather, is also in news. And Iceland basically is on top of a divergent plate boundary. How many of you have followed the volcanic eruptions which are occurring in the region of Iceland? Have we followed that? No? So just try to follow it up. In the region of Iceland, there are a series of volcanic eruptions which are happening close to the capital city of Reykjavik. And basically, that is because, and there, if you observe the eruption, the mode of eruption is very different from the normal volcanoes that you would have seen in videos where on top of a conical peak, molten materials emerge. In Iceland, if you get an opportunity even today or tomorrow, I know you have a very busy schedule. So even today or tomorrow when you get time, take a look at the videos of what is happening in Iceland. Now, there the method of eruption is very different. A large crack opens up on the ground surface and molten materials, they start emerging upwards. So that is one of the characteristics of the divergent plates. Nonetheless, divergent plates represent what? They basically represent the movement of the plates away from each other. As the plates, they tend to move away from each other. That is what is the divergence of plates. Now, why do they move away from each other? Again, because of the presence of a convection current. Because of the presence of convection current underneath, as long as the convection current shall be prevalent, there shall be that away movement of each other. And as a consequence of that, as these plates, they tend to move away, in the gaps, you will have the newer crust, which keeps on getting solidified. Okay, so that is the case of divergence of plates, plates moving away from each other. Now, in this case, we have seen yesterday also with the help of seafloor spreading that whenever there is the movement of land masses away from each other, and let's suppose there is emergence of molten materials, the molten materials will solidify in between. You will have creation of a newer crust, isn't it? Always, and in most of the cases, you will have the creation of a newer crust. And that is why because there is a construction of a newer crust across these plate margins, that is why this is also what is referred to as a constructive plate margin. Constructive plate margin. Now, with the same logic, if I take you back to the convergence of plate. Now, convergent plates, we have seen that in the case where two plates, they collide with each other, one of the heavier one will ideally get subducted underneath the other, or maybe there will be creation of a fold. But in either ways, the boundary of the plate is getting destroyed, it is getting consumed. That is why convergent plate boundaries, they are also what are referred to as boundaries. They are also what are referred to as destructive plate margins. They are known as destructive plate margins. Okay, and divergent plates, where you have a creation of a newer crust, you have the constructive plate margins. Now, where do you observe the divergence of plates? Wherever you have the presence of convection current underneath, in the region of asthenosphere, in the region of lower mantle, that is where divergence is observed. For example, if you observe here, this is your Arabian plate, this is the portion of Arabian plate, and this is your African plate. Now, African plate and Arabian plate were at one point of time, they were joined with each other. But now, over a period of time, there has been a convection current which has come underneath them, and there is a divergence of plates. That is why here across these areas, you will observe the formation of Red Sea. And this divergence further continues into the region of Africa also. Okay, so that is where you have the kind of a divergence. And observe, as the plates are diverging here, as this Arabian plate is moving like this, it is moving almost parallel to the existing plate here in this area. In this area also, it is moving parallel to each other. So where the plates are moving parallel to each other, these boundaries are known as the transform plate boundaries. Okay, so this is the region around Turkey, around the region of Israel, for example. In these areas, Syria, in these areas, you also have the transform plate boundaries. Okay, so that is basically the case of divergence. Now, as the Arabian plate is moving away from the African plate, it is converging with the region of the Asian area. That is the region around Iran. It is basically converging with that area. Now, divergent plates create variety of landforms, including mid-oceanic ridges, right, underneath the oceanic water. That is where, observe, these are your mid-oceanic ridges, This is the divergence of plates. And these are the regions of active volcanism. Many of the times what also will happen, that as the molten materials, they start coming up, as the molten materials, they start erupting, these molten materials will start to solidify here itself. And sometimes the molten materials, they can pile up and lead to formation of islands as well. How? So for example, let's suppose you have a plate like this. Right? Now, ideally, if we are talking about oceanic areas, this is the region under water. Now, sometimes it also happens that as there is divergence due to the convection current, now here, molten materials might also rise up and they might begin to pile up over this area. Okay, the molten materials might begin to pile up in this area. Eventually, they might emerge above the surface of water, and that will lead to the formation of volcanic islands here also. Formation of volcanic islands. Now we have also seen that when we talk about divergence in the case of the oceanic areas, in the case of the continental areas, so first of all, as there is divergence, we have seen this earlier also. If I can take you back to that particular image, if I can bring you back to that image, observe, as there is divergence here, as the plates basically are pulled away, they, because of the tension, the central portion which develops the cracks, that central portion, there is nothing holding it together anymore. So you will have formation of depressions or rift valleys. Rift basically represents a kind of a tension. So there is a formation of rift valleys in this case. So for example, observe this. This is a kind of a rift valley. Okay, this is the image of African, East African rift valleys. Okay, that is the example of East African rift valley, where you will observe that as these plates are moving away from each other, you will find that there is, observe, the middle portion is simply sinking down. Now this is a very long depression. Don't think about it as a small ditch, because all these tiny whitish structures that you observe, these are well larger structures of homes, right? So 2 to 3 story buildings, many of them they represent. So that is where the entirety of region of East Africa, that is basically moving away from the region of the remaining portion of Africa, because there is a convection current which has emerged underneath the portion of Africa. And as a consequence of that, you have this divergence leading to the formation and creation of rift valleys. So here you have volcanic eruptions also, and across these regions you will find the presence of mid-oceanic ridges. Mid-oceanic ridges become the centers of divergence. It is here where Iceland lies. Observe, Iceland basically is at the divergence point between the regions of Eurasian plate and the North American plate. Here volcanic eruption has created the island. Okay, We will study later that the kind of volcanic eruption that occurs in this case, that is also what is known as the Icelandic eruption. Here you have another kind of a divergence which is occurring, Pacific plate, and this one is the Nazca plate. Nazca plate. Right. So here basically you will observe that there is a divergence. Now this is also what is referred to as these mid-oceanic ridges up between the Pacific and the Nazca plate, by the way. That is also what is referred to as the East Pacific Rise or the Chilean Rise. Okay. This is what is known as, the name is East Pacific Rise. Pacific Rise or Chilean Rise. Why I have given you this name is, I have not given you other names, is because as of now, the rate of divergence anywhere across the planet is maximum in this area. The rate of divergence is absolute maximum in this area. In this area, plates are diverging at a rate of, currently, plates are diverging at a rate of 15 centimeter per year. Something at a rate with which India was moving millions of years ago, that is happening in between the Pacific plate and the Nazca plate. Observe that here also there is a divergence. Here also there is a divergence consistently. It is the divergence which is happening across this area which is pushing India to collide with the Eurasian plate. Here also you have a divergence. Now as we speak, for a few 100,000 years in the past, that is for the recent time period of around 500,000 to a million years, there has been an active divergence happening here as well in this area. This is what is also referred to as the East African rift. So what do we mean by this? That means in the near time future of a few million years, you will find that this portion of Africa is going to separate from the rest of the landmass. Let me use another color which is visible. This portion of Africa is going to get separated from the remainder of the portion of the continent, and the remaining portion of Africa is going to collide with the Eurasian landmass. And remember, here you have the Aegean, the Ionian Sea, which is again a remnant of the old ancient Tethyan sea floor. So here again, as Africa will collide with Eurasia, just like we have seen the formation of Himalayas, here also you will find the formation of another mountain range, another fold mountain range, as the rest of the African continent is going to join with Europe. Obviously, in the next 15 to 20 million years is something that you will find this. Okay. Now, in this case, you will find a certain kind of volcanic eruption in the regions of divergence. I want to show you this image of that kind of a volcanic eruption here itself. So if I can basically show you that volcanic eruption, here you will observe these kinds of volcanic eruptions, something which is being observed in Iceland. Here in this image, I hope you are able to see this image. In this image, I hope you are able to see that how there is a large crack almost on the ground surface, almost a very large crack. So in these cases, there is a divergence, and this divergence will open up these cracks. And as these cracks will open up, You will have volcanic matter which will start emerging out. That is what is happening in the region of Iceland. These are fissure volcanoes. Fissure, basically, the meaning of fissure is crack. So when we talk about fissure volcanoes, we are talking about a large crack opening up where there shall be volcanic eruption which shall happen. You know, in 1700s, in 1770s, you basically had a volcanic eruption in this region of Iceland. Now that was the what was referred to as the Laki eruption. And during that eruption, you won't believe, but a large crack having a dimension of 37 kilometers. Think about it. From your house, measure any particular distance which is around 37 or 40 kilometers. So that much distance. A 37-kilometer long crack opened up, and you had continuous upwelling of molten materials, upward movement of molten materials. They continued to come up from the surface for many months, and you had these regular movement of volcanic material continuing for a few years. It is said that in the Laki eruption, you had close to around thousands of kilometer cube. Kilometer cube represents volume. Thousands of kilometer cube of molten materials were actually expelled during this Laki eruption in Iceland. So Iceland, that is why, is a center of these kind of volcanic eruptions. And Iceland earns a good amount of money out of volcano tourism. Right? Iceland, basically, if you will observe, if you want to explore the region of Iceland, they earn out of volcano tourism. They will have their entire theme developed around volcanoes, that we will take you to visit volcanoes or older volcanic areas, etc. So the entirety of the region of Iceland is very active volcanically because it is at a point of divergence between the North American plate on one side and Eurasian plate on the other side. Now I want you to apply a logic here. So basically, if you talk about, let's suppose, divergence of plates. So let's suppose this is a plate, this is another plate. Okay. Now here, molten materials are trying to come up because there is divergence of plate. Now, generally the molten materials will come out easily, but sometimes it might happen that the rate of divergence or the rate of movement is not the same as much the molten materials they try to come out. So sometimes here also what you will observe is that the molten materials, they try to come out along with the gases and the liquid, they will continue to hit the landmass. Unless and until the landmass cracks open, they will continue to hit the landmass. So every time that these molten materials come up with a force and hit the landmass, will you experience something on the landmass, or will that force be too minor for you to experience? What do you think? Will there be a force experienced on the landmass? Yes? Yes. So that is why always in the regions of divergence, sometimes you observe minor earthquakes. And minor earthquakes means basically minor shaking of the land surface, because the molten materials there, they try to hit the surface. So that is why there will be shaking of the landmass as they will come up and hit the surface. This is the reason that, you know, the volcano in Iceland erupted yesterday, right? Day before yesterday, basically in the last 1.5 days, that is when the volcanic eruption occurred. But for the past 1 month, Iceland has experienced 800 earthquakes only in the past 1 month. 800 earthquakes, which tells you that the molten materials, they are trying to come up. That is why in the regions of these divergences, when you have too much amount of earthquakes, that is a kind of a symbol or a kind of a signal that molten materials are trying to emerge out of the surface. They are waiting for a crack to open up that is when evacuations they begin to happen. Similarly, when we were talking about the convergence of the plates, remember in the point of convergences, we talked about the fact that the oceanic, whenever we talk about oceanic continent or oceanic, the oceanic crust goes down, but that movement won't be smooth. That movement will be staggered. Whenever there will be sudden movement, there will be emergence or expulsion of huge amount of energy which will basically shake the earth's surface. We experience that as earthquakes also. But we also know that whenever there is that sudden movement or there is the movement of the oceanic plate, subduction of the oceanic plate, eventually the oceanic plate will go to a depth. That is when they will start melting. Molten materials will rise as volcanoes. So whenever there are active earthquakes happening in the region, for example, of oceanic convergence, that is always a harbinger or a kind of a foreteller of an idea that volcanic eruptions can happen in the near term future here. Because that means more oceanic plate is going down, it will melt, it will rise up in the next couple of years. For example, if you would have witnessed or noticed the current affairs for the past month, you would have observed that the eastern coast of Philippines, that this entire region around Mariana Trench, that is where a lot of earthquakes have occurred. That means the Pacific Sea floor is undergoing subduction. And that means in the near term future, Philippines, that is in the next 2 to 3 years, Philippines will experience volcanism. In fact, you have no particular, this should not come as a surprise, that basically you have Mount Tal in Philippines already indicating signs of volcanism due to the movement of the Pacific plate, right? So this is always correlated. Plate movement is always correlated with each other. So that is the case of the divergence of the plates. Then we have the transform plates. What do we mean by transform plates? Transform plates mean when the plates move parallel to each other. Move parallel to each other. Now, will they be able to create new crust, or would they be destroying the older crust? No. So if they are moving parallel to each other, they would neither create a newer crust nor destroy an existing crust. Right. So that is why these are also what are known as conservative plate margins. Conservative plate margins. That is, neither create or destroy an existing crust. Now here again I want you to apply the same logic. You have the plates which are neither moving towards or against, they are moving parallel. Do one thing. Close the fist of your hands, right, of the palms. Now here, in the corrugation of your fingers, the indentation that your fingers have, try to move both of the fist with respect to each other. It is not a smooth movement, is it? There is a resistance that you feel. Imagine the rocks in this case. So as they try to move parallel to each other, there will be a lot of resistance. And they will suddenly, because there is a continuous movement being pushed by the convection current somewhere else, they will eventually be able to overcome that and have a sudden movement. So that will again lead to the shaking of the earth's surface. And that is why here also you will experience very high magnitude earthquakes as they move. So in these areas also, across these plate margins, very high magnitude earthquakes. Magnitude earthquakes. Are basically observed. Very high magnitude earthquakes are observed even in these areas. Now here, as the plates they try to rub against each other, as the plates they try to move against each other, sometimes what happens is you have cracks which develop here. In these areas, you will have cracks because obviously the rocks, as they're trying to move with respect to each other, the movement won't be smooth. So the rocks develop some cracks. Earthquakes, they center around these cracks. One of these is basically the San Andreas Fault, which is present in the region of California in western part of North America. That is a center of very high magnitude earthquakes. So in this case, the plates move parallel to each other, neither creating or nor destroying a feature. It leads to significant tension being built up and creation of earthquakes and faults. Example, San Andreas Fault in California. Okay, San Andreas and the development of San Andreas Fault in California. Now here, I have told you that convergence of plates will also have earthquakes. Divergence of plates will also have earthquakes. Transform movement of plates will also have earthquakes. But all of them won't be of the same magnitude. Apply your logic that in which of the cases the shaking of the earth's surface will be slightly minimum, slightly less. Across width of these plate margins, think about it, take a random guess. The shaking of the earth's surface will be comparatively very less. Very good. Amritansh, Shiva, Godavari, Megha, Debanjan, Githyon, Sarojini, Swaim, Yug Singh, Seema, Vijay Lakshmi, Brajneet, Akash, Krishika, Santosh. Correct. Kittu, Tabassum, Jyoti, Sakshi, Prem Kumar, Mansi, Abdullah, Vikalp. Correct. So in divergence of plates, the shaking of the surface will be minimum. Why? That is because in those areas, the land is already trying to move away from each other. So already the existing forces, the land trying to move away from each other, creating less resistance for the volcanic matter to come out. But when we talk about either the transform movement or the convergence, there is a lot of resistance. That is why earthquakes of least magnitude are observed in the regions of divergence of plates. Earthquakes of very high magnitude are observed in the region of convergence and sometimes even transform. Very high magnitude earthquakes. Okay, so that is basically the case of the plate movements. These are your major plates, and this is the plate movement. Use this map for your revision also. Now, I want you to observe these areas. Observe this region. Himalayas, all the way into the region of Jammu Kashmir, Afghanistan, Pakistan, Iran. You would hear frequent news stories about earthquakes rocking in this area. Earthquakes basically dominant in this area. Why? You have convergence of plates. But other than the Himalayan region in India, there is another area in our country which is very frequently experiencing earthquakes, which does experience high magnitude earthquakes very frequently, almost once every 50 or 100 years. There is a very destructive earthquake other than the Himalayan region, which occurs in other part of the country. Can you guess that? Good. Abdullah. Twisha, correct. Prem Kumar, Vibhu, Akash. I'm talking about India, Brajneet, not Pacific Ring of Fire. Sushmit, correct. It is basically the region of Gujarat. You would have heard about the very infamous Bhuj earthquake. Bhuj earthquake literally destroyed the entire area. We had around 10,000 unofficial figures take that number to close around 10,000 people who perished there, right? Large cracks opened up on the ground surface because of the shaking of the earth's surface. So why does Gujarat experience so much amount of earthquake? Because if you take a look at the region of Gujarat, Gujarat lies at the boundary of three plates. Yes. Gujarat lies on the boundary of three plates. And that is Indian plate, Eurasian plate, and which is the other plate? Eurasian plate, and then the minor Arabian plate. So if there is any movement in any of these plates, be it the Indian plate moving northwards or the Eurasian plate coming southwards or the Arabian plate moving, any of these plate movements which happen, and they will happen eventually, isn't it? Massive earthquakes, they rock this area. That is why in 1800s, you see, it is not as if the Bhuj earthquake which happened in Gujarat in 26th of January 2001, that was the only earthquake. No. In 1800s, in the first decade, couple of decades of 1800s, you had such a massive earthquake happening in the region of Rann of Kutch that you had, as the rocks, they basically moved with respect to each other, the plates they moved to with respect to each other. Think about it. Suppose, imagine if you have one of these plates, another one of these plates, and in between the rocks, obviously the fragment of rocks will be present. So as the plates they would move, sometimes the rocks get uplifted. So you know what? Many of these earthquakes, they have given a rise or led to a condition where land has come above sea sometimes. And at the same time, you had a massive earthquake in 1819, during which a significant portion of land simply sunk underneath the water because of that earthquake. That is why the region of Gujarat, over the period of hundreds and thousands of years, it has experienced so many devastating earthquakes. Many of the regions have gone under the sea. Many of the regions have emerged over the sea. That is where the entire story that you hear about a kind of a drowned city, a sunken city of Dwarka, you would have heard about it in mythological tales. You would have heard about it if you live in Gujarat, if you have been to Gujarat, there are many stories about the ancient city of Dwarka, which actually went under the sea. That is where those stories they come from. Because Gujarat typically has witnessed that the existing landmass simply sinks. Because as the rocks they try to move, a small rock portion in that adjustment might break from underneath and it sinks, it is consumed. And it can also happen that as these rocks they churn out, some small portion of landmass emerges up. And here observe, again, observe here. There is convergence here. This is the reason why across this entirety of area spreading into Bay of Bengal also, you have significant amount of earthquakes happening in this area. And here, there is convergence in this area. I want you to observe this portion, the region of Andaman Nicobar. Here, the convergence which is happening, what will you classify this convergence in the region of Bay of Bengal? Will that be continental, continental, oceanic, oceanic, or oceanic, continental in the region of Bay of Bengal? What kind of convergence will be there? Oceanic, oceanic, very good. There will be oceanic crust of the portion of Indian plate colliding with the oceanic crust of the minor Burmese plate here. So it is oceanic, oceanic convergence here. Now in oceanic, oceanic convergence, just think about it. Tell me the kind of landforms which get created during the time of oceanic, oceanic convergence. What are the landforms which get created? Islands, then other than island, trench. Very good. And these islands are volcanic in nature, isn't it? That is why to the east here in the region of Andaman Nicobar, you will find the only active volcano of India. That is the Barren Island volcano to the east of Andamans. And here in the region of the Andaman Nicobar Islands, slightly to the west of it, you will find the minor Andaman Trench also in existence. So this is the reason why these islands of Andaman Nicobar, if you now take a look at the map sometimes in detail, you will find the shape of Andaman Nicobar Islands across this arc. It is because there convergence is happening. And then this African plate is also breaking into two here. This portion of Africa is going to collide here. Mediterranean Sea, etc. will disappear. But as this Mediterranean is getting converged here and is getting sandwiched between Eurasian plate and African plate, do you recall something similarity to what we have seen in the formation of Himalayas? In the formation of Himalayas, you had the Tethys Sea. Now, when the Tethys Sea was getting subducted, or from both ends it was getting subducted, what happened? Volcanic eruptions happen. That is why southern portion of Italy is dominated by a series of volcanoes. For example, you basically have Stromboli, Mount Etna, Volcano, all these various different types of volcanoes and volcanic peaks are observed in the southern portion of Italy. And here again, as the African plate is pushing here, on the margins, you will have formation of fold mountains. Which are these fold mountains known as? What are the fold mountains present here known as? Atlas Mountains. Very good. That is the Atlas Mountain. Here, as there is convergence with the Nazca plate, you have a fold mountain along with volcanic peaks which get created here. What are the name of these mountains? Beautiful. Andes. Here in North America, you have two series of mountains. One is present far away from the coast, and these are known as Rockies. Good. And the one which is absolutely at the coast, which is the youngest fold mountain getting created, what is it known as? The Cascade Ranges. Beautiful. In fact, it was the continental convergence which led to the formation of a mountain range here. Which is the mountain range here? The Ural mountain range. Okay, there is a formation of another fold mountain range here. And what is that mountain range known as? Caucasus. Very good. Alps are again formed due to this convergence. Alps are present here. You have another fold mountains formed as at one point of time this small landmass collided with Europe, and that led to the formation of a mountain chain here in between Spain, Portugal, and the region of France. I had given you for the mapping of that also. What is that known as? No. That is the mountain range. Find it in the atlas. It is Pyrenees. Alps are situated here. These are your Alps. These are your Pyrenees. Here, at one point of time, the North American plate did collide. Before the divergence, it did collide with Eurasia, and that led to the formation of Appalachians here. Okay, and as we speak here, you will observe that there is a crack which is developing in this area to the west of Indonesia. The region of Australia is moving like this, India is moving like this. So the Indo-Australian plate over the next few years is going to break into a separate Indian plate and an Australian plate. Here observe you have the Philippine Sea plate, the Caroline plate. It is underneath these newer oceanic plates that the older Pacific plate is undergoing subduction. And that is why here you will have the Mariana Trench and volcanic peaks such as Mount Pinatubo, Mount Tal, and here observe the region of Japan. That is why experiences volcanism in the form of Mount Fuji and series of very intense and high magnitude earthquakes along with the formation of Japan and Kuril Trench. So that is how I hope you are able to visualize what happens across the world, and more importantly, what is going to happen in the future. Okay? Now, then a couple of questions here. Which of the following phenomena might have influenced the evolution of organisms? How is it that evolution of organisms happen? As they adapt to newer conditions. That is how evolution happens. So which of them have influenced the evolution of organisms? Correct. Majority of you are correct. Both 1 and 2. Even glacial cycles, that is frequent existence of ice age and the melting, that has also helped the organisms evolve. Newer species have evolved, and the continental drift as it happened, there also newer climates were exposed, so there also evolution was influenced. Now, which of the following pairs are correctly matched? Here is the theory or the law, and here is the associated scientist. So, continental drift, expansion of universe, photoelectric effect. Which of them are correctly matched? 30 seconds should suffice in this case. This should be easy. I expect many of you to get it correct. Yes. Good. Very good. So, continental drift was provided by Alfred Wegener, incorrectly matched. Expansion of universe was provided by Edwin Hubble, incorrectly matched. Photoelectric effect was provided by Albert Einstein. So this is basically B3 only. Why wouldn't you have done this correctly in the new format? You do know about continental drift and expansion of universe. That would have been sufficient. That only one, even if it is only one option is correct, only two option is correct. And even if you have not studied photoelectric effect right now, wait till you study science and tech, you will basically get an idea about that. Okay. Now, in the structure of the planet Earth, below the mantle, the core is mainly made up of which of the following? This I expect at least 90% of you to get it correct. Please don't disappoint me in this case. This is one of the easier ones. At least 90% of you should get it correct. Because I've given up hope for 100%. So, okay. Chalo, I'll make do with 82% also. I'm an accommodating fellow. So here the correct answer is iron. So that is basically some of the PYQs. And now we move on into the portion of earthquakes, volcanoes, faults, and faults. This is just going to be a kind of a, okay, leaderboard. Right. I understand. So those of you who have got it correct basically would want to see your name in the leaderboard. You get that Kaun Banega Crorepati kind of a feeling, right? So almost all of you have got it correct, and then it is based upon the time taken to get it correct. Okay, so if your name is not there in this list, don't worry, these many of you have got it correct, all three of them. Okay, right? See, those of you who get it incorrect, you are never interested in leaderboard, but when you get it correct, obviously. So basically, now we come to the portion of earthquakes, volcanoes, faults, and faults. For the prelims here, what is going to be relevant is seismic waves. Even this year, you had a question directly picked up from what we talk in the PPT about. So this is one of the areas, basics of P and S waves. Then after that, shadow zone. Then after that, when we talk about, let's suppose, intensity and magnitude of an earthquake, then basics of volcanoes, then after that the portion of types of magma and lava based on chemical properties. Then after that, intrusive volcanic landforms. Here generally match the following kind of a question can be asked, that is name of landform, the shape that they have. Now, this is an area frequented in the mains examination also, both for your GS as well as for your optional. So here, global distribution of earthquakes. Global distribution of earthquakes. Induced seismicity. Shadow zone, first of all, can also be asked. Shadow zones, the basic concept. Induced seismicity. Global distribution of volcanoes. Then after that, you can also have a question associated with, let's suppose, hotspots and mantle plume. It is from these areas that questions have been asked and the questions which can also be asked. Okay. Now, we start first of all with the portion of earthquakes. So when we talk about earthquakes, what is an earthquake? So the shaking of the earth's surface. When the earth's surface gets disturbed, it starts shaking up. That is what is an earthquake. Right? It can happen because of variety of reasons. It can happen at a variety of depth. But in a nutshell, generally you will observe that energy is released somewhere in the interior. That energy may be of a kind where, let's suppose, the frictional forces are overcome. Right? The forces of friction exerted on one as compared to other, let's suppose that might be overcome. That can also lead to an earthquake. Right? Sometimes it can happen that in one area, the molten material, they are facing a lot of resistance, and that resistance might be overcome. Let's suppose you have plates which are trying to move with respect to each other. We have seen in the case of convergence. Now, initially there will be friction, and suddenly, let's suppose, that friction is overcome. So the point in the interior where that energy is released, that is the origin point of an earthquake. That is what is also referred to as the focus of the earthquake. So when we talk about focus, point in the interior, where energy is released. Force acting interior of planet is called earthquake? Absolutely not. The forces acting from the interior, they are known as endogenic forces. Earthquake is just one of those endogenic forces. I will show you the entire classification of it. So the point in their interior where that energy is released, that is known as the focus of an earthquake. But how do you use that for reference? For example, let's suppose you talk about focus is also the origin of earthquake. Let's suppose earthquake has occurred somewhere in the interior of the zone of convergence between the Eurasian and the Indian plate at a depth of around 60 kilometers, let's suppose. Now, how do you refer to it? That where the earthquake has occurred. What will be your point of reference? So for that, you draw basically, you have a point on the ground which is perpendicular to the focus. That is the epicenter. So on the surface, the point immediately above the focus, generally used for referring to the origin of the earthquake on the surface, that is the epicenter. So epicenter is directly above the region of focus. Okay, epicenter point on the surface above the focus. Okay, that is what we refer to as the epicenter. Now the focus can lie anywhere, wherever, let's suppose there is divergence or convergence, etc. Any point of time there might be a resistance which might be faced and it can be overcome. So depending upon the focus, there is a classification of an earthquake into shallow focus earthquake, shallow focus, where the earthquake occurs at a depth of around 0 to around 100 kilometer. Generally around 0 to 60 kilometer is taken as shallow focus, but in certain classification you will also find 0 to 100 kilometer. Then you have intermediate focus. Now point of intermediate focus is generally at a depth of roughly around 100 to 300 kilometer depth. And then you have deep focus. Deep focus earthquakes, they lie at a depth of around 300 to 700 kilometers. If let's suppose you have a question that why is it that beyond this you don't have the occurrence of or origin of earthquake, is because of the fact that at a depth greater than this, let's suppose there is a kind of tension or a kind of a compression, or let's suppose any friction. At that depth, the temperature is so high and the pressure is so high, rather than the materials overcoming that friction, they get deformed easily. Right? So if let's suppose a material is trying to go down here and it is unable to move at that depth, it will simply get deformed. So that is why earthquakes beneath the depth of 700 kilometers is never experienced. Now here again apply your common sense. Out of the shallow, intermediate and deep focus earthquake, which is going to cause maximum damage? Which has got the maximum damage causing potential? Beautiful. Very good. It is always going to be shallow focus earthquakes, because in that case the energy has been released very close to the surface. So that will shake the earth's surface very significantly. Always. Okay? So for example, we have seen the convergence of plates. Now convergence of plates always will lead to shallow, most of the times will lead to shallow focus earthquakes. Transform plate movement also sometimes lead to very shallow focus earthquakes. But convergence sometimes, as the plates are converging, sometimes the plates will go. Some portion of it might melt in the region of asthenosphere, but as it pushes further, convergence can lead to deep focus earthquakes also in certain areas. Okay. Now, when we talk about an earthquake, basically, you have to understand that our knowledge, our idea about these internal phenomena, that has rapidly accelerated in the past 100 years or 110, 120 years. We have already talked about it, that how 1900s have been the pinnacle of this scientific discovery. Raheen, what is it that you are unable to understand, my dear friend? सर थोड़ा एक्सप्लेन करके बताइए. Okay. What is it that you are unable to explain? Understand? Let me know. In case you have attended the previous sessions, in the first class only I put a conditionality that you have to be regular in the sessions. Otherwise, you cannot expect, because you would have understood till now that how each and every class we are basically building up on the previous concept. It is always going to be a build up on the previous concept, and the same logic, the same approach we are going to follow for the rest of the geography. So everything is basically each concept is going to lead to the next chapter. So Raheen, please tell me, which is the portion in which you want me to explain a bit more? Okay. So I'll wait for your answer. Till that point of time, we will move ahead. Why convection current is somewhere causing divergence and somewhere convergence? Isn't it something, Ashish, that we had addressed yesterday about why the plates move? Did you miss out on that? Again, it is a simple thing. If you have a plate here, A, B, look at the annotations. In case you are missing a session, obviously because you would have some very pressing needs, that is why you might be missing a session. Maybe the Prime Minister or the Cabinet Minister would have called you up, and it is something that you could not come through. So basically, in that case, before coming to the next session, the minimum that you should do is take a look at the previous one. So here, let's suppose, okay, Ashish, look at it carefully, because I had written it in the annotations of the PPT yesterday. If there is a convection current here between B and C, right? So B and C are going to move away from each other. But what about A and B? So A and B, what kind of movement will be there, Ashish? Please let me know. A and B, will there be convergence, divergence, or transform? Convergence. C and D, what kind of movement will be there? Convergence, divergence, or transform? Convergent. So here you have one convection current which is leading to divergence in these areas, convergence in the other areas. Is that understood now? Right? Let's suppose you have multiple of these plates. If the two plates, they are getting pushed aside, they will basically get smashed somewhere else. Isn't it? Is that making sense? Right? I hope that is making sense. Yes? Okay. Now, Sudeepa, basically when we talk about the focus of the earthquake, that is where the energy is released. Let's suppose you have the convergence of the plates. Yeah, let's suppose. Now one plate is going down. Now it might happen that the resistance is offered or experienced here. It might happen that the resistance is experienced here. It might happen that the resistance is experienced here. Right? Anywhere the resistance might be experienced. And wherever it is overcome, there will be sudden movement and release of energy. If release of energy happens here, shallow focus. Basically, wherever the energy is released, that is the focus. If it happens at a lesser depth, shallow. If it happens in between, intermediate. If it happens at a greater depth, deep focus earthquake. Okay? Right? Now, can we say that divergence movement on seafloor is leading to convergence or shrinking of the Pacific? Yes, it is. Very good, Prem. Energy we mean in earthquake is same as the convection energy? No. No. Not always will the convection current translate into the same amount of movement. Some of that energy, convection current might even be consumed in melting some portions, in basically the volcanic eruption. So it will not always translate. Okay. Then how transform boundaries, how do they occur? This also we had covered yesterday. Why are these doubts emerging today all of a sudden? We have covered it with the help of the map itself. Observe here, we had talked about it that if this is moving, North American plate and the Eurasian plate, they are moving away from each other. The African plate and the region of South American plate are moving away from each other. So it will not always be the case that here also the rate of divergence is the same, here also the rate of divergence is the same. It can happen that the rate of divergence here is less, the rate of divergence here is more. So in this entirety of the area, the plate will experience a kind of a parallel movement, but at different rates. So there will be a crack which will be opened up. That is how transform plates. Is that understood now, above? How we will get to know that plates are older or younger? I mean, you want to know, or how do the scientists get to know it? Scientists, they get to know it by studying the rocks and the radiocarbon dating. Why there will be convergence between A and B? Because A is also moving in the direction B is also moving. There is a divergence here. Observe this. There is a divergence here. Divergence is happening because of convection current. So as this convection current is happening, it is pushing the Indian plate here. Does that mean that the Eurasian plate will also be pushed? No. So here Indian plate will be colliding with the Eurasian plate. There is a divergence occurring here in the region of the African plate. The portion of the African plate is getting pushed here. So does that mean that the Eurasian plate will also be pushed along with it? No. If that would have been the case, one convection current would have ruptured the entire planet. There is divergence happening here. There is divergence happening here. So the South American plate is getting pushed here. Here there is a convection, there is a divergence. So here the Nazca plate and the South American plate, they are convergent with each other. Is that digestible, Nikhat? Is that understood or no? Okay, I think it is not understood. I hope you understand. I hope you get the larger picture that when we talk about, or let me take you to this image, which we had seen earlier. If I hope you are aware that if there is divergence here, does not mean that this divergence will be impacting the Indian plate also. Is that the doubt? And please be responsive after you have asked a question, and if I'm addressing the question, be responsive. Okay, tell me, what is convergent? If there is A and if there is B, if this is colliding with A, won't that be referred to as convergent? Convergent means what? There is a collision. Relative motion is towards each other. Is that understood? Convergence does not always mean that both of them have to be pushed towards each other. But nonetheless, there is convergence here. For example, let's suppose it is, in this case, the Pacific plate is getting subducted here. Now, North American plate in this portion is not moving that much, but the Pacific plate is subducting here. What will you call this? If the Pacific plate is getting subducted there and the North American plate stays in its own place, what will you call this? Will you call it divergent or transform or convergent? Convergent, isn't it? Vaibhav, is the rate of speed of both the converging plates same? Why will they be same? Why will be this they be same? It is depending upon where the convection current is released. That convection current. So what you are basically postulating and talking about, Vaibhav, is the fact that if this is the planet Earth, if this is the region of, let's suppose, the portion of core, so what you are saying is that convection current in all these places will be of equal densities and equal intensity. Can that be a reality when we are talking about a spherical planet which has a radius of 6,370 kilometers almost? Can you think about it that from all areas, like a flame on the gas, it will emit equal amount of energy? Obviously not. Earth is not a perfect sphere, right? When Rift Valley is created, the water in the picture that's filled is that saline water. Yes, from the nearby sea or the ocean, it fills in. Akash, yes, that is true. So now we move forward. More deeper focus it will go. We will not be able to experience earthquake as it is much deeper. Yes, that is true. Do we have the map based distribution of different convection currents in the interior of Earth? No, because convection current is not always fixed in the same area. Convection current at one point of time drove the region of North America into collision with Eurasia. Or in fact, sometimes the convection current can change. So if you are open to it, I will introduce you to another concept, but I'm afraid that it will confuse you beyond your comfort level, and I don't want to do that. There is something which is known as Wilson cycle. Are we aware of the Wilson cycle? There is something which is known as the Wilson cycle. So Tuzo Wilson, who was basically credited with the entirety of much of the formulation of plate tectonic, this is named after Tuzo Wilson. Tuzo Wilson is the guy who basically came up with the name tectonic, which means building. So Tuzo Wilson postulated a theory which tells you that, look, the present day continents, or the planet rather, yes, Subhadharani, very good. So Wilson cycle basically talks about the fact that the planet every few 100 million years goes through a phase, and it is consistent, and that is every few 100,000 years, or every few 100 million years, you have one supercontinent which gets created. Initially you had the creation of the landmass. Now over a period of time, due to convection currents and heat released from interior, the land masses, they keep on getting divided. They keep on getting divided. So as they get divided, you have formation of various different continents. These continents, they move with respect to each other, towards, away from each other. Eventually, after a few 100 million years, again, as they move, it is a sphere. So if, let's suppose, the objects are moving away from each other, eventually it can lead to a collision also. So eventually again they will come together and lead to formation of another supercontinent. That supercontinent again can get divided into various different parts due to the convection current. And as it gets divided again, the land masses, they will move away from each other. You will have formation of multiple continents. Again, these continents basically will eventually come together and form another supercontinent. And that again will get divided. This process keeps on repeating across the planet. Till now, based upon the geological evidences, we have seen the formation of three supercontinents. We have the evidence at least of two significantly. The middle one is not so certain, but we have the earliest supercontinent, which was known as Rodinia. That is the name given to the earliest supercontinent. That supercontinent is said to have been broken into multiple different continents which existed for a very long period of time. Species did exist, various species existed on those continents. Rodinia then came together again to form Pangaea. In fact, it is said that in between Rodinia and Pangaea, there was another supercontinent which got created. Pangaea is the most recent or the latest of these supercontinents which got created. Right? So till now, from the portion of continental drift theory, we have initiated the discussion from Pangaea itself. But before Pangaea also, you had earlier supercontinents which were created and which got divided. And in fact, if you take a detailed look into the history, is that digestible? First of all, it is important to know that. Is that digestible? Can you wrap your head around that imagination? Yes? Good. So basically, that is how the cycle in the planet, it keeps on going. Now, if you take a look at the cycle of life, when life for the first time got introduced underwater, few of the species, they went over land roughly around 600 million years ago. It is said that when they went over land, it was not Pangaea, it was Rodinia at that point of time. Species, they started growing. Many of the species, many of the plants, they emerged. And then you had such significant volcanic activities rocking the entirety of the planet that many of them, they got divided. Many of the species, they went extinct. Again, everything came together. And when Pangaea was created, it was a desert. The interior regions of Pangaea was so very large. Interior regions could never get any rainfall. Life would be restricted into the coastal areas itself. That is when you had the growth of reptiles, lizards. In fact, Atacama Desert has been dry since the time of the formation of Pangaea itself. And then it was at that time when Pangaea was created. That is when eventually you had the dinosaurs. And that is when the Pangaea got divided. Dinosaurs, they split into various continents with no competition. And they dominated the world unlike anything else. So in the next few 100 million years, again, everything will come together. And there will be another supercontinent there. That is why when I tell you about the region, let's suppose, here, after a few 100 million years, this entire land mass will be one. This entire land mass, Australia will join this area from the side in the region of the Pacific. Australia will join this. And eventually Pacific plate will be consumed. North America and South America will join this here. Again, there will be another supercontinent created, barring Antarctica, which eventually is going to get joined here also. So that is how, again, a third or the fourth supercontinent will get created. Like that, with the help of the convection current, the Earth continues to release its heat from the interior in a continuous manner. Is that understood? Is it possible with continuing cycle, the amount of land keep on decreasing? Newer land also gets created. More volcanic eruption happens. For example, 95 million years ago, You had such a violent spate of volcanic activities that the islands of Caribbean that you see, that got created due to the volcanic eruption, the base lava which emerged across the planet. And that was one of the times when so much amount of volcanic eruption happened. The entire region that we refer to as Deccan Traps in India, that got created, or lava deposits in that region got created because of that. Okay, right? I hope that is understood. It has got nothing to do with Jurassic World. Please don't get that misconception that Jurassic World will tell you about Pangea and the Rodinia. Okay, so I hope this is understood, and that basically is something which you inculcate. If the two plates are diverging, Vaibhav, you are at the same question after all of this. If the two plates are diverging, is it possible that the plates move in different speed? Obviously, yes, my dear friend. From yesterday, I have been repeating this consistently. As the two, see, at the point of divergence, the speed will be same because it is diverging. So if this is diverging at, so what we say as the speed or the rate of divergence, it is how they are diverging away from each other. When we say rate of convergence, can it be the case that Eurasian plate is converging at a slower rate, Indian plate is converging at a faster rate? No. Indian plate might be moving at a